Okay, so this is the second video. We're still solving log equations. This time you notice that it's different than last time. And the reason it's different is because I only have one log. In the previous video, we had them on both sides. This one, you only get one of them. So that's how you know when do I do the one thing versus the other thing. When you just have one log, we're going to do it a different way. In the previous video, we had one on each side, and then they just dropped. This time, we're going to have to do something to solve this because just looking at it, we can't just, quickly, easily set something equal to each other. We can't just drop anything. So this one's a little bit different. This is going to go back to where we need to convert it. So remember we said y equals the base to the x, and then we converted it to log baby base of y equals x. Okay, so that was our conversion. We're going to have to do that again. So again, if that order in which I wrote it is confusing, you can rewrite it in whichever way works for you. Right here, this is my log base of y. Yeah, the y is like a whole, expression here, equals, and here's my x. Okay, I'm going to have to rewrite this. So this was my base, this was my y, and this is my x. So if I'm going to rewrite this to make it look like this, remember this is exponential form. And again, I have to do that because I can't easily drop something or set something equal here. So I'm going to rewrite it. And by rewriting it in exponential form, I'm going to be able to simplify some numbers and I'll be able to solve it. So y equals, so my y was 4x plus 1. So y equals the base to the power of x. So my base was 7 and my x was 4. Okay, so this helps us because 7 to the 4th power is actually a number. I don't actually know what that number is, but we're going to find it right now. So 7 to the 4th power. So we're going to go into Desmos. I've got 7. I'm going to use this a to the b because that's how you get a power other than 2. And I'm going to put 4. So that gives me 2,401. 2,401. Now, if you don't, you have access to Desmos, you're doing this computer, exponents you can do on any calculator. So if you have a different calculator, you have the one on your phone and you can turn it and get the kind of extended functions. You don't necessarily need Desmos. It's just easier for me to show you on Desmos. Okay, so now I can solve this. So 4x plus 1 did not change. But now I can solve it. It's a two-step equation. So I'm going to subtract 1 from both sides. I'm trying to get x alone. I'm doing the reverse of order of operations. Okay, so I'm left with 2,400. Okay, x still isn't alone. Same kind of last step we've seen a million times. 4 is being multiplied by x, so to undo that, I'm going to divide it. Okay, so x equals, this goes in here 6 times and 0, 0. So my answer is 600. So you're going to get big numbers. That's okay. There's nothing wrong with that. So please don't feel like if I get a big number, something's wrong. No, that's going to happen. You could have small numbers. You can have big numbers. It doesn't actually matter. It's totally fine. That is my solution, 600. Okay, so I'm going to do another example. So I'm going to come over here. We're still going to use this idea. We're still going to use this idea here where we have to convert it to exponential. And again, how do I know I need to do that? I know I need to do that because I do not have log on both sides. It doesn't say log base 2 over here and log base 2 over here. That's how I know something else has got to happen. So we're going to do just like what we did before. I find it helpful to label. This is my base. This is my y. This is my x. I find that helpful. If that's not helpful to you, then don't do that. Okay, so we know y, so that's our 5x minus 17 equals our base, which is 2 to the 3rd power. Okay, now I know what 2 to the 3rd power is. It's 8. But if you did not know that, you could easily just go back to Desmos and do 2 to the power of 3. So 5x minus 17 equals 8. So remember, this is an exponent. This isn't 2 times 3. That would give me 6. This is 2 times 2 times 2. 2 times itself 3 times. Okay, so now I've got a two-step equation. So notice that by rewriting this in exponential form, I totally get rid of that word log. Like it's gone. It doesn't even matter. I just end up with these normal equations. So I'm going to need to get the constant to the other side. So I'm going to add 17 on both sides. That makes that go away. I have 5x equals 25. And again, I'm still trying to solve for x. Not there yet, but if I divide both sides by 5 to undo that multiplication, and I do what I do to one side, I do to the other, I'm left with an answer of 5. So notice this number is not a large number. And again, that's fine. I don't want you to anticipate that all numbers are going to look a certain way. I will tell you that all the answers on big ideas are whole numbers. None of them are decimals. None of them need to be rounded. I know how much you love that. So this is the second type of problem. One more time. How do I know the difference between them? This only has the word log or natural log once. This is when you convert it to exponential. When you have the word log or natural log on both sides, that's when you just drop that and set them equal to each other.